every time I sit there and I bring something else up, it gets longer and longer to be able to go live. I guess YouTube just wants to sit there and go, oh my gosh, you're going live 3 separate times. Oh my goodness. Everything's going good. Kind of get going here real quick. A second to get this up and going online. Looks like we are. Looks like it caught me right at the worksheet, which is for the packet, which is good. There we go. There, I hear my echo there of myself. Yeehaw! Yeehaw! Hello, everybody. Hello, 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 hello. How are we doing on this April the 21st, 2020? April 21st, 2020. Plugging along with this just absolutely awesome, awesome year of 2020. Second here, and then we will get going. We will what I'm going to do is I'm going to get straight into this. And again, for those of us who are following along, on demand, since that's what it's looking like here, on demand, then we will just know that this is covering topic 2. I'm going to try to keep my mug off the screen here to try to keep my mug off the screen so you can be able to see everything going on. Dealing with just starting right off here. So we're talking about combining like terms to solve. So again, it tells you with your quick review, you can use variables to represent unknown quantities. To solve an equation, collect like terms to get one variable on one side of the equation. This was that thing for you guys that were going over this. We're like, oh my gosh, you thought I was doing, you thought I was doing torture almost in a way when we were doing this. But again, you're going to use your inverse operations and properties of equality to solve the equation. Again, anything here is what we are talking about. So when you look at number 1 there, hey, what's up, Joe? How you doing, man? So when you look at this here and you look at solving each equation for x, so when you solve each equation for x, and you have on this, you're going to combine your like terms. So you combine your like terms here on that. So if you have 2x and then you're adding 6x, you have 2x and you're adding 6x. I'm doing number 1 right here. 2x plus 6x is going to give us 8x. 8x equals 1,000. And your inverse, you have 8 times x. How do we get rid of 8 if we're multiplying 8? We're going to divide by 8. When we cancel out 1,000 divided by 8, 1,000 divided by 8 will give us 125. So when we solve that equation for x, x is going to equal 125. 125. 125. Clear that off. Pull right through it here. If I were to add 2 and 1/4 x, and then I added another 1/2 x. Miss you too, dude. I hope everything's going well. Okay, I hope everything's going well. With everything going on and stuff, I said I hope everything's going well. So if we have 2 and 1/4 x, and then we add that extra half, it's going to make it be 2 and 3/4 x. equals 44 equals 44. And just remember with this, when we have a mixed number, so if we have a mixed number here, 2 and 3/4, we want to get that to an improper fraction. When we do that, multiply our bottom. 2 times 4 is 8, plus 3 is 11. 11 over 4. Make it 11 over 4x equals 44. And then to get rid of that fraction, if you remember, if you don't, that's okay too. We're going to multiply by what we call the reciprocal. You multiply both sides. Remember what you do to one side, you do to the other. You multiply by the reciprocal, the 411 and the 114 will cancel out and leave us with x. It's okay. So it's okay. It's okay. Like I said, it's just to kind of it's just to kind of go through these things. Again, you got the questions, reach out. I mean, it's just to kind of suffice for being out since out since March and everything. So like I said, I hope things are going well and hi Raquel. So when we have our right side here, can the number 11 go into the number 44? Can we reduce those? Can we reduce those? And the answer to this is yes. 11 divided by 11 is 1. 44 divided by 11 is 4. 4 times 4 is 16. 16 will be your answer for number 2. For number 2. All right. If you guys have any specific questions on that, just stop me. If you have any questions about anything, just as I'm doing this, just stop me and like I said, I'm looking at the chat here, so stop me. I'll be more than happy to further explain things. I just kind of want to. The idea of this is to is to go through and to review this and to make sure at least we get somewhat of a semblance of understanding about everything. Um, let's go to number 3. So number 3, if I have a negative 2.3x and then I subtract 4.2x to this, and it's going to equal negative 66.3. You're kind of probably all sitting there going, oh my gosh, there's all these negative numbers, good grief. First thing you want to do, change that second part to its plus negative. And then you're going to take negative 4.2x and get more negative by adding negative 2.3x. When you do that, add these together, it's going to give you negative 6.5. X is going to equal negative 66. Making sure I did that right. And then when you divide both sides here, when you divide your 66.3 by 6.5, it's going to give you 10.2. When you divide both sides, I had to double check my math on that, by a negative 6.5, x is going to equal, because a negative divided by a negative is going to be a positive 10.2. Okay, again, combining your like terms to solve it. It's just basically, it's taking this to a higher level. The base of finding this, you can say, just to be able to understand, especially when you guys for 8th grade, when you get into things such as some of the stuff you'll see, if you guys pursue, keep going further and further, you'll be kind of going like, oh my goodness. So let's roll down number 2. I won't take too long with this, but just to kind of rehash what we had talked about way back at the beginning. If you have 3x plus 9x equals 6x plus 42, our goal is to get x to one side. And it tells you if two quantities represent equal amounts and have the same variables, you can set the expressions equal. You want to collect all the variables on one side of the equation and all the constants on the other side. That's when I would always sit there and say, get x to one side, get x to one side. That's what basically what we're trying to say right there. And then use inverse operations and properties of equality to solve the equation. So 3x plus 9x is 12x equals 6x plus 42. And again, you want to get x to one side. I want to subtract 6x from both sides. When I do that, it leaves my right side at 42. 12x minus 6x is 6x. Hello, hello, hello. To solve for x, we're going to divide both sides by 6. And when we do that, 42 divided by 6 is 7. Is 7. Is 7. Okay. Again, you're collecting all the variables on one side of the equation and all the constants on the other side. On the other side. On the other side. Let me do real quick. Let me do 3 real quick here. Again, you want to combine your like terms. So, and then get your x's to one side. So 9x minus 5x is going to be 4x plus 18 equals 2x plus 34. Again, let's get the x's to one side. Let's get the x's to one side. It's going to leave our right side at 34. And our left side at 2x plus 18, and that is an x. We then want to subtract 18 from both sides. And as you see, it is a lot of writing. As you see what's up, Malachi? What's up? What's up, Brianna? What's up, everybody? What's up? What's up? Again, I'm a little delayed with the, I'm like on a delay here with everything, so if I don't give you the shout out, I'm sorry. But yeah, I see everybody here. I mean, it's good. That's good to see you guys. It really is. It really is. 34 minus 18 is going to be 16. And then when you divide both sides by 2, x is going to be 8. All that writing to see x equaling 8. I know. Such fun stuff. Such fun stuff. Let's do one more. And those of you who are kind of joining with me a little bit later here, if you haven't figured it out by the YouTube topic here, I'm talking about topic 2 through my packet that was created. Just to kind of go over some of the stuff we did. This is the stuff we had done at the way beginning of the year. Everybody kind of was like, "Oh my gosh, this is interesting stuff." Let's do one of these on 2, 3. So you're talking about multi-step, and this is, I think, where everybody kind of got a little bit kind of. So solve each equation for x. First thing you're doing, let's start. 4x plus 4 plus 2x, and this is all algebra. All this is just all algebra. So you have to distribute first. 4 times x is 4x. You're going to bring down that sign, that plus sign. 4 times 4 is 16. And then write your remainder plus 2x equals 52. Okay. Now, what would you want to do? You want to combine your like terms. 4x plus 2x is going to give us 6x plus 16 is going to equal 52. And again, You want to get x by itself, so you want to sit there and then subtract 16 from both sides on this instance. 6x is going to equal, and I'm blanking out myself here, that should be 36, I believe. Yeah. I guess I shouldn't have used green on green, but so my apologies. And then divide both sides by 6. X is going to equal 6. And x equals 6. Okay. X equals 6 for that. All right. What I'm just wondering is if it's ever going to get like consistently warm and consistently nice. I'm looking out my window I have over here, and you just see this wind is blowing back and forth, and it's just like, oh, you ever noticed? For those of you who've been on live streams with me, so how long I've been doing this, I talk about the weather all the time. So that's just my weirdness. So let's here. We can come back and talk about the infinitely many solutions. We talked about this yesterday. We talked about the proportional relationships and then dealing with proportional relationships and slope. Basically sitting here and saying, if you're trying to connect the fact that a proportion is set to the same rise, well, if you're looking at me, the same rise over the run. So your change in y over your change in x. Remember, x goes this way, y goes this way. Um, again, you know, again, it's me knocking on that screen up there and saying, okay, you're finding slope by finding your change in y over your change in x. Okay, and I'm be sitting there and saying, you know, going y equals mx plus b, and you find your m by finding your change in y, your change in x. And I laughed because I remember I was making everybody crack up. I think I lost my voice after that. Change in y over change in x, and then b was your y-intercept. The y-intercept was where it crosses that y-axis. So where that line would cross that y-axis. I know we were making some good progress there when it came to going in March there, in February, March, and kind of going over, creating your equations, doing everything in that sort. Um, one of the those one of the things we're kind of making good progress, and then getting kind of separated like we are here. Kind of that's the kind of one of the issues here. Let's see. So let's go down to where it says here. So like in this instance, understanding that y-intercept of a line. So the y-intercept of a line, and I would hammer it into the head there, y equals mx plus b. Y equals mx plus b. And you see on this, it says the equation y equals 5 plus 0.5x represents the cost of getting a car wash and using the vacuum for x minutes. Okay. Number one, what is the y-intercept? Where does this line cross that y-axis? Where does it touch it at? Where does it touch it at? And you see that it is at the number 5. It's at the number 5 in that instance. Okay. If you did not even know this part right here, you crossed this out and you were like, I was just looking just purely at this graph. If I was purely looking at that graph, I could say, if it asks you what's the y-intercept, it's where does the line touch that y-axis at? And I can't draw any more arrows enough to explain that, to say that, all right, that y-intercept is where it crosses or it touches that y-axis at. That y-intercept is at 5. Is at 5 in that instance. So what does that y-intercept represent? Now, here's the thing. What does that y-intercept represent? Let's look. If you're doing a car wash, and you're comparing the number of minutes to the cost, the number of minutes to the cost on this instance. If at 0 minutes, your cost is $5, you have to be able to make that correlation. It represents the cost of getting a car wash and then using that vacuum for X minutes. So it's saying to yourself, for every minute you're using the vacuum, why they should put vacuum here next to that. It's supposed to be vacuum. Every minute you're using that vacuum, the price goes up. It looks like by 50 cents. So that slope is 50 cents, just to show it. And then that y-intercept is 5. So the y-intercept represents the initial cost of getting a car wash. So that cost of getting a car wash is going to be $5. So that cost of car wash is $5. Is $5. Okay. Let me clear that screen. Finally. Finally here, let's go with, I'm going to do 2 just because it's hard for me to draw the line on this. So what is the equation of the line? So what's the equation? This was kind of the stuff more recently we had kind of worked with, just to a different degree. Stay with your y equals mx plus b. So your y equals mx plus b. B is the y-intercept. Start plugging in your information. The y-intercept is the number, it looks like the number 3. So your y-intercept is the number 3. Okay. If y-intercept is 3 and b is the y-intercept, I can put the number 3 here. And then what is our slope? What is our, and this is why I might have to zoom in a little bit. Anything to remember here? There we go. Get that off here. So your change in y over your change in x. If you start off here, we're at your y-intercept. I go down 1, so it's a -1, and then over 1. So it's a negative, looks like a -1. Not mistaken. Let me make sure I got the right thing. Yeah, -1 over positive. So +1 there. So negative divided by a positive is a negative. So simply put, y equals -x plus 3. I get rid of the 1 because, well, it's just 1. So technically this is -1x. Technically that's -1x. But the slope is, but in this instance, the slope is down 1. The slope is down 1 and then to the right 1. Okay. Like I said, anything to really hammer home that point, because when you get further and further along, I mean, slopes and y-intercepts, and then when you get to x-intercepts, stuff we really didn't get a chance to get through just because of, leaving it March. We're going to try our best to get through here, but this is just a kind of review and get through everything. Again, I hope you all are doing well. I hope you all are doing well. If you have any questions, again, with anything, just reach out and everything. Here, again, my information off of, with Google Classroom. So again, you can always send me an email. Reach out via Google Classroom. I'm here to answer questions. Got anything going on, let me know. Otherwise, I hope you all have a great day. Have a great week. Please make good decisions. That being said, I bid you all adieu. Have yourselves a wonderful day. See you guys.